Welcome viewers. In this video we will see the interconnection of two-port network in that series connection of a two-port network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, series connection of a two-port network. When the two-port network is connected in series, what is the parameter we need to analyze? When the two-port networks are connected in cascade, the parameters of the interconnected network can be conveniently expressed with the help of ABCD parameters. We know that in the two-port network there are 6 parameters available: Z parameter, Y parameter, ABCD parameter, A dash, B dash, C dash, D dash parameter, hybrid parameter, inverse hybrid parameter. So we can use in this parameter for this interconnection of network. In that it is connected in cascade. Suppose the networks are connected in cascade, means more than one devices are connected in a particular manner. Then we can use the ABCD parameters. In a similar way, the Z parameter can be used to describe the parameters of series connected two-port network. If it is series connected, then we can use the Z parameters. Then Y parameter can be used to describe the parameters of parallel connected two-port network. So series connected we can use Z parameter, parallel connected we can use Y parameter. We know that series connected means the current flow will be same in both the network. Parallel means the voltage will be same, current will be different. Based on that we can able to understand what is series connected and parallel connected. Now the series connection of two-port network is shown in the diagram. The diagram is available in that two networks X and Y. X and Y are connected in series. So this is the network X, network Y. So input current I1. This is the output current, output port current I2. This I1 is flowing in the network S, it become I1X. Then it will go to the next network, then it become a I1Y. Then it is going outside. So the I1 is the input port current. While entering into X network, it is I1X. While entering into, leaving into Y network, it is I1Y. Similarly, the output current, output port current I2. While entering X, it become I2X. While leaving, it become I2Y. So this V1 is the voltage in the input port with both X and Y, common to X and Y. Similarly, V2 is the output port voltage. V1X is the voltage in the network X. V1Y is the voltage in the network Y. Similarly, V2X is the voltage in the network X in the output port. V2Y is the voltage in the Y network in the output port. So from this diagram the current is same. The I1 is flowing. It become I1X. Then I1Y. The same current is flowing between X and Y. That's why it's called a series connected. Similarly in the output port I2, I2X, I2Y all are same. So from this diagram we are able to give the some expressions. So I1 equal to I1X, that is equal to I1Y. All the current in the input port are same. The total current flowing through the X network and Y network in a input port all are same. Similarly in the output port I2, total current I2 equal to I2X, that is equal to I2Y. Current flowing through X network and current flowing through Y network in a output side all are equal. All currents are equal. Similarly the voltage, the total voltage V1 is nothing but sum of V1X plus V1Y. Right? So this total voltage is applied, that is split into two. So sum of these two is nothing but total voltage V1X, V1Y in the input side. Similarly this V2 is the sum of V2X and V2Y. So V2 equal to V2X plus V2Y. So this is the relation we got from the series connection. We know that series connection means current will be same. The voltage will be sum of individual network, right? So we can use this parameter while analyzing the network parameters. If each port has a common reference node for its input and output, and if these references are connected together, then the equation of the network X and Y in terms of Z parameter. So we have a common reference node. Then we can express this network X and Y in terms of Z parameter. We already discussed for series connected network, Z parameter can be used. Similarly, parallel connected network, Y parameter can be used. Now we'll see the Z parameter, how to express Z parameter for this series connected two-port network. So first we will see the Z parameter, the equations. V1 equal to Z11 I1 plus Z12 into I2. V2 equal to Z21 I1 plus Z22 into I2. So V1, V2 is nothing but the voltage in input port and output port. I1, I2 are the current in input and output port. Z11, Z12, Z21, Z22 are the Z parameters. So the voltage in input and output port are expressed in terms of current in input and output port. V1 and V2 are expressed in terms of I1 and I2. So here we are using the two network, X network and Y network, so that we can write V1X equal to Z11X into I1X, Z12X plus I2X. Similarly, V2X equal to Z21X I1X plus Z22X into I2X. So everywhere we added X. Similarly, Y. V1Y equal to Z11Y I1Y plus Z12Y into I2Y. V2Y equal to Z21Y into I1Y plus Z22Y into I2Y. So for a series connected network, we already discussed I1 equal to I1X, that is equal to I1Y. Similarly, I2 equal to I2X, that is equal to I2Y. The voltage is sum of these two. V1X plus V1Y is total voltage V1. V2 is nothing but V2X plus V2Y. Now these two networks are connected in series, so that we can add this value V1X and V1. V1X and V1Y can be added in the input port. V2X and V2Y can be added as a output port. So now it is added. V1 equal to, this is the parameter in the X network, this is the Y network. Both are added together. So in this I1 equal to I1X, that is equal to I1Y. Similarly, I2 equal to I2X, that is equal to I2Y. So now we are going to substitute this I1X, this I1X and I1Y can be replaced as I1. Similarly, I2X and I2Y can be replaced as I2, right? I1X, I1Y both are I1. I2X, I2Y both are equal to I2. Now we'll take this I1 common. Here also I1 available, here also I1 available. Take common. So Z11X plus Z11Y. Then I2 available in the second and fourth term. Take I2 common. So Z12X plus Z12Y. So this Z11X plus Z11Y can be totally written as Z11 generally. Similarly, Z12X plus Z12Y can be written as Z12. We can make it as Z12. Now we'll go to the V2, the voltage equation in the output port. This is the X term, X network. This is Y network. So here I1 equal to I1X, I1 that is equal to I1Y. Very similar to previous. Here also I2 can be replaced as I2X, I2Y. Both are equal. So this I1X, I1Y is replaced as I1. I2X and I2Y is replaced by I2. Now take this I1 is common, available in first term and third term. Take it outside. So Z21X, Z21Y. Similarly, I2 available in second and fourth term. Take outside. So it is Z22X plus Z22Y. So this Z21X, Z21Y can be written as Z21. Similarly, Z22X plus Z22Y can be written as Z22. Right? So that is written in the next step. So V1 equal to, this is written as Z11 into I1 plus Z12 into I2. So that is written. Similarly, V2 equal to Z21. This Z21X, 21Y is written as Z21. Similarly, Z22. So these values are again written separately. Z11 is nothing but Z1X plus Z1Y. Z21 is Z21X plus Z21Y. Z12 is Z12X plus Z12Y. Z22 is Z22X plus Z22Y. Now what is the conclusion from this? That is the important. In series network, finally we got this Z parameters. What is the conclusion? We see that each Z parameters of a series connected network is given as the sum of the corresponding parameters of the individual network. So the total Z parameter is nothing but sum of individual networks. So if if the networks are connected in series, the individual parameters can be added together to get the final parameter. Right? The total Z parameter is nothing but sum of individual network parameters. That is the conclusion we got. Right? Z11 equal to Z1X plus Z1Y. So each Z parameter of series network is sum of the corresponding parameters of individual network. All individual network parameters can be added together. That is the conclusion we got at the after analyzing, we got the conclusion. So in this video we discuss interconnection of two-port network in that series connected network, two-port network. If it is connected in cascade, that is in a different way, then we can use ABCD parameter. Series connected means Z parameter. Parallel connected means Y parameter. We discussed the diagram. From that we got the relation for current and voltage. We know that series connected means current is equal. Same current is flowing in both the network. Voltage is sum of, total voltage is sum of voltage across the network. Based on that we analyzed and we substituted the value. Finally we got the Z parameter is the sum of individual parameter of each network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.